The screen sharing open?
Yeah, I do.
Oh, we already have some participants. Hello, everyone. Welcome. Where are you coming from? Oh, hello, UK. Good to have you here with us. Has any of you used behavior trees or our previous package, Muse Behavior? Max, I think it is only you. Awesome. More from the USA. Oh, that's really cool, Sean. Yes, Alexander, so exciting. I can't wait to share it with you. Hey, it's Trevor. Welcome, Trevor. We know you. Well, Christopher, you'll get some of that right now. Some people from Greece. Still need to visit Greece. Oh, there is a poll going on. Poll, sorry, English, which I'm asked to mention and have you look at it and fill it in. This is what happens when you let two engineers run a webinar. It's gonna be great. I get to answer the poll too. Cool. Oh no, it says we cannot vote. We're gonna start in just about a minute. So see if more people join us. I guess there is a lot going on right now and quite a few people are busy. There is someone having some audio issues. I think, Max, maybe you should try to rejoin. You're also sending the messages to the hosts only, so other participants can see it. You can change the settings in the two before you send. Oh, dialogue trees. Well, hopefully it can help. Although it is a bit more on the behavioral tree side. All right, let's get started then. Thank you all for joining us today. Can everyone see my screen okay? Morgan, you said it was running well, right?
Yeah.
That's cool.
Yeah, you can see your
Okay.
screen.
So we are here to introduce to you our new behavior package, Some of you might be familiar already with Muse behavior. This is soon coming out as just behavior, which should focus only on the behavior tree tool. It will still have the generative AI stuff, but as an addition. First, let us introduce ourselves. So I'm Shani Mishri. I'm the lead engineer on the behavior team. And with me is Morgan, my colleague.
Greetings from Stratford-upon-Avon. Yeah, I'm also part of the team.
We are really excited to share with you what we have. So let's start with what we're going to cover today. So, oh, sorry, my second screen obviously went mad right now. There we go. So we're going to start with what is behavior and why are we doing this? Then we're going to move on to the features and a live demo by Morgan. And then a little bit about what's coming. And finally, some time for Q&A for you all to ask your questions. So let's get started. What is behavior and why are we doing this? This is a big part of the why. We want to bridge the gap between creativity and engineering. We want to make it easier to collaborate and to give you a more high-level way to control the workflow of your game. So behavior started as a behavior tree tool, but it evolved to a much bigger thing. It is now a high-level event graph. You can use it for behavior trees, and you can use it to do other things like your gameplay and system and control multiple different characters at the same time. In my own game prototype, I've actually been using it as a little bit of a cinematic machine as well to when a character gets to a point and it starts playing interaction between different characters. It's also not a visual scripting solution. It's not here to replace visual scripting. It doesn't pretend to be one of those. It doesn't give you access to all the low-level details and functionalities in Unity. Instead, it lets you create high-level nodes, or as low-level as you wish them to be. And every node is backed by a C# class that a programmer has to implement. This is partially because we also don't want any reflection for high-performance runtime. Let's talk a bit more about why we are doing this. So basically, every game developer out there probably needs some kind of AI in their game, or if not AI, some kind of interactions, behaviors, interactivity. And it's not just games, even applications and industry use need it. Even things that don't have agents running in their game might still have things that are interactive or reacting at you in some way or another. The other thing is, it's just been a bit difficult to bring those kind of interactions in Unity. So we try to make a tool that will make it easier and fun to actually use. And the last part is that users have been asking for this quite a while. In fact, we have already seen quite a few people in the chat mention it. And many of us at Unity are actually game developers as well. So we wanted it. We know we needed it, and we started it to. And so now we're excited to bring it over to you as well. Now, our goals with this package is to empower creatives, people that might not be technical, to be able to do more and do it more easily. So soon you'll see how with the graph, a non-technical person can create the flow of their game or their behaviors with much ease. And then an engineer, a programmer, can just jump into that high-level flow, right-click any of these nodes, any of these actions, and jump straight into the code and implement them. So with those two, we want to create a lot more interaction between the two disciplinaries and just increase the collaboration and make it a lot easier. For me, as a programmer, I find it a lot more fun as well to use it and then jump into the code and then back into that, as opposed to just moving C# scripts around. You'll see more of that soon. We also have a few extra goals. The first one maybe is a little bit cheeky. We want to be able to allow users to have patch-free updates to their games. So if you have your own CMS or your content delivery system, you should be able to just deliver new behaviors as part of an asset bundle, because it's just a scriptable object. And finally is usability. We want to make it a lot more usable by making the behavior trees a lot easier to read, a lot easier to grasp right out of the box. So anyone who sees it knows exactly what's going on. And we are also doing it by getting rid of this lovely spaghetti mess that we're also familiar with graph tools and behavior tree tools. So let's talk a little bit about our features and how we're doing all of this. The first part is our unique take into behavior trees, where all of the data is right there for you on the nodes themselves. So a node can be an action. If you're familiar with the behavior trees, you also have composites and decorators, which we call modifiers. And you can either type in your values directly into the field, or you can link them to your Blackboard and share them across your graph elsewhere. The idea is that anyone who reads this knows that the villager is going to say hello there or a pre-made greeting. The second part is that we're going at it from top to bottom and left to right, just like you'd read a book, just like you'd read a script to a play, which is what your NPCs are going to follow after all. So instead of having noodles and edges connecting every single node, instead just drag and drop them, make connections, and remove a lot of the mess that we would otherwise have. Now, this is what we believe is the way forward. Behavior graphs or our event graph should be design driven. So any designer or any non-technical person can create their nodes, can create their actions, just using simple sentences which will show them exactly what will be on the graph. And you'll see high resolution demo of it soon when Morgan shows you the demo. And we've worked very hard on making a bunch of nodes that we believe all of you will probably want to use by default. We also want to bring more of those. So if you have any feedback on what you'd like to see, jump in the community later on and let us know. And finally, of course, every behavior at some point is going to encounter an error, some kind of interaction that won't work properly. So it needs to be debuggable. And for that, we can show you the state of the running graphs in real time. Now, everything has to have real production value. It needs to be usable in your game somehow. So part of it is, as I mentioned before, this is all driven by scriptable objects. You can share them through asset bundles. You can move them to different games. And we are even bringing a dynamic graph feature, so you can change which graph you're going to run at runtime within a different graph, by changing different subgraphs and changing a variable controlling which graph it is. And finally, nearly every game needs some kind of way to save and load the state. So we've made all kinds of APIs for you so you can do exactly that. Being able to control the state of your graph, being able to save it, reload it, and start exactly where you start. All right, with that, I'll move over to Morgan, who will show us a live demo. You ready, Morgan?
Yeah, have to. Thank you, Shani. So it's my turn. I'll start by saying that the team has been working very hard preparing 1.0, and yet we also wanted to provide a new and useful demos that would demonstrate a variety of use cases, because actually the tool can be used for much more than just AI. But I won't tell more for now. Instead, now I'm going to craft a small bit of that upcoming demo, and I'll show how to get started while creating a patrol behavior. So I will share my screen. Oh, actually, sorry, I forgot the small optimized video sharing. Okay, everything should be fine. Can you see my screen? I will assume it's a yes. Okay, thank you. As you can see, I will not start from scratch. I've already got a small test scene here with a nav mesh, a few system. I've got like a player that can move around, and we've got our agent that is going to patrol around the scene. So on the agent itself, he already has a nav mesh agent, and he also has this sphere collider as a trigger that will be used as a detection area. And he also have an animator to animate when he moves, kind of thing. So for this demo, I'm going to assume the role of a game designer. So I know how to code a little, but yeah, overall, if I could not code, that would be very nice. So let's get started. First, we want a graph. So a graph is just a scriptable object. So in the project tab, right click, create behavior graph, and you've got a new graph. Let's call it patrol. I'm going to open it. So here is my blank graph. By default, you will always get on start node. But yeah, you can see that we also got this inspector and blackboard window. The blackboard just being kind of a collection of variable that can be used inside of the graph. And I'm actually going to rename you to agent. And by default, graph blackboard always have the age self like that represents the graph owner in the scene. And then the inspector is going to be used to either describe by default the graph itself or to describe the node we are focusing. So right now, like I said, I'm a game designer. I'm not too sure where to start, but I've created these small documents to describe my scenario. So I'm actually going to copy this description, and I'm going to use this edit subgraph representation feature that will basically allow me to input my description. And as you can see, I can then assign a type to each
Hold on,
individual
Logan,
board.
sorry.
Sorry?
People are saying there is a blue box on top of the blackboard.
Oh,
Yeah, maybe you should try resharing your screen.
all right. Thank you.
Yeah, there we go.
Is it better?
No, it's
No.
still showing. Technical difficulties.
A black.
You could just move it up to the top left. It should be better then, maybe.
Yeah,
I
if
think.
you, yeah, it's just on
Okay.
your bottom right of the screen for some reason. Like
Oh yeah, I
where-
can see it on the stream. It seems to be where the zoom icon comes up, but okay, that's weird. All right. We have to adjust, I guess. I'll move my scene here. Sorry about that. All right.
If
Okay.
you move the blackboard, Morgan, to the top left in the graph here, it might be a bit easier also.
Yeah. Well. Yeah. We'll do our best. All right. Okay. Hopefully everything should be fine now. So yeah, I was saying, with the description, you can assign a type to each of these words. And so, for instance, I know that my target here is going to be the player, and it's going to be a game object. And I know that I will need to patrol around checkpoints. So I'm going to use here a list of game object. And then I've got this allies. I know from my document that I might need something for allies in the end, but I'm not too sure quite what yet, but I'm just going to add another game object list here, just in case. So I'm gonna hit confirm. And now you can see that it automatically populated my blackboard with this value. All right, all of that is nice and stuff, but to be honest, I would like to see something moving. So I'm going to start looking at the node built in and that I could use. So there's a lot of categories, but I know I've got NavMesh. So I'm going to take a look at the navigation nodes, and here I've got a patrol. Let's focus it and see what the description says. So move a game object along waypoints. Well, that's basically what I need. So you can see that on my nodes, there is just two variable where in the inspector I can get even more data if available. So in this case, I know that my checkpoints are my waypoints, so I'm going to assign that. I will need a speed, so I'm just going to create a new one. Call it patrol speed. I'm going to assign default value of 2. Then the other thing seems good, and animator speed param. I actually have a speed floats parameter in my animator, so I'm going to set the name and preserve latest patrol points. Not too sure what this is about, but hopefully there is tooltip. All right, so let's save and go back to the scene. All right. So now we have our graph, but we'll need the graph to actually be on the scene. So I could select my agent and add a behavior agent, or pro tips, I could drag and drop the graph directly on the game object. And as you can see, the blackboard variable has been reflected on the in the inspector, and so I will be able to assign my checkpoints here. I'll just put 3 of them. Should be enough for the demo. Let's save and hit play. Okay, seems to be working fine. All right, let's go back to the graph. Let's double check our scenario. Okay, we know now I know that I need 3 states, and my instinct tells me to do kind of state machine to handle that. So I would like to use enumeration to create my state machine. Let's see what I can do. So add enumeration. Character state is something else, but I've got this wizard to create a new enum, so let's use it. Patrol states. Idle. Investigate. And all that. Let's save it here. And so what this is being done here is basically just creating a normal C# enum and adding the Blackboard enum attribute on top of it. And this is the only requirement to add an enum to your graph. So as you can see, the variable has been automatically added. So I'm going to rename it here, but it states so it's shorter. And now I would like to be able to create my state machine. Let's see what node I can use. So probably something in flow and conditional switch. Yes, it's doing exactly what I need. Well, obviously. All right, now I'm going to go back to my scenario, and I basically want for the idle 2 different behavior running. One being the patrol, and the second a wait for the target to enter the investigation area, or if you can remember in the scene, the detection area. So this is a sphere collider, and it's a trigger. Let's see if we have a node that can be used here. Action, physics, and wait for trigger. Perfect. Wait for an on-trigger event on a specific agent. So my agent is already assigned. We'll wait for enter. I know my player has a player tag, and I guess this is, yes, the out value. So I can get my target from here. I will do that. And in case we've got a target, I would like to change states. And to do that, I will have to use the set variable value. I combine them, and now I'm going to assign states and change the state to investigate. Now I just have to connect my nodes to the states. What's that? Oh, yes. Most of the nodes can only have one child. So in this case, I would like this behavior to run in parallel. Let's do that, and nice. Okay, it's nice, but it starts to get a little bit messy. I'm going to use Alt-A to align the first child, or Alt-Shift-A to align all the children. That's better. Okay, and now let's just for debug purposes, add a log here. Debug log. Don't investigate. So we know that when this condition is reached, we are getting a log. Set out. Okay, let's do it. I'm going to use to activate the gizmo, so we got a better. Oops, sorry, I actually disabled. Okay, let's do it again. All right. Seems like it doesn't work. Let's see what's happening. Going to reopen the graph. And let's attach the debugger. Let's run again. So we can see that the graph is running, that the agent is patrolling, and is waiting for the trigger. That's it. It did work, but the graph is still running. Oh, I understand why. So this node, the patrol is basically going to make the agent patrol forever. So we need a way to abort this action to restart the state machine. Okay, let's see what we have here. So let's go back to flow, and well, there is an abort or restart. Restart branch when assigned condition are met. Yes, that's exactly what we need. All right, let's assign. And let's assign a condition. So I'm going to use variable value change because this is exactly what we need. So now when state change, it's going to restart the state machine. Simple. Let's try again. Yep, it's working. Amazing. And as we can see in the console. All right. So we've done already 1/3 of it. Let's see what's come to next. So next we also got 2 behavior. One being the investigation, where we would like the AI to look around, and if it sees nothing, it go back to idle. And the second one is a condition about checking that the target is in the file of view. So let's do that quickly. Let's get rid of that. So I'm going to start by waiting a bit. Let's use wait range. I'm gonna wait between half a second and a second. And then I would like something, because I would like the agent to turn right or left, but I don't want it to be predictable. And so here's a random branch. Let's use that. Now something to make my actor rotate.
Just don't forget to move your black box from the blue rectangle at the bottom right.
All right, sorry. Let's click on the rotates node, and the inspector show us that there is actually a duration.
People are also asking to maybe try to reshare again, because there is some kind of a delay, a video lag between your audio.
I'm really sorry. Oops, let's do that again.
Sorry, everyone.
Thank you. I hope it's going to be better now. Okay, so on my rotate node, I've got the transform to rotate. So I'm going to use agent. And as you can see, my agent is a game object. but this is actually taking a transform. So there is an implicit cast here. And I'm going to rotate it 120 degree to the right. And I will also use this duration over 1 second. I'm going to duplicate the node and add it here. And now I will wait again, like another range. You know what? I'm just going to copy paste. But this time I'm going to just wait a little bit longer. Oh yes, again, nodes can only, most of the nodes can only have one child. So here I will have to decide whether it needs to wait for all nodes before continuing or for any of the nodes. So here, any are good. So we're going to do that. I'm going to align everything with Alt-Shift-A. And I'm going to wait a bit longer here. And after that, if nothing aborted this behavior, that means we can go back to idle. All right. Now, I will want something for my condition. I would like, so there is an action conditional guard, allow flow to pass only if the specified condition are met. All right, let's use that. Oh yes, because again, behavior needs to run in parallel. Let's do that. But quite a lot of ND helpers here. So let's use a condition, check file of view. Oh, I know that's something another designer did. And you know what, I'm just going to reuse it. It should work hopefully. So let's use the agent as the origin and the target. We already have a target for it. And 90 degrees is exactly what I need. And in case this condition is met, I would like to wait for small timing. Like just to say it's not too brutal. And we're going to change the state to alert. All right. And I would like something else than just a log this time to debug it. I wonder if there is anything more visual. Resources. Oh, can actually play particle system. Play particle system to the target location. All right. I know that we have a nice exclamation mark. So let's use this one. And the targets should be not the target, but my agent. And I will add a small offset so it's above him. And oh, there is actually a pooling mechanism built in. That's useful. All right, I'm going to save and I'm going to keep the graph on the side just to debug it. Okay, and let's hit play. So let's sneak behind him. That's nice. Looks nice. Let's. Okay, it looks like it's working fine. That's nice. Let's do another try. Let's remove the gizmo. Yep. Right, and I'm going here. Ah, he didn't notice me. Why? Let's try again. No, it's not working. Why? Let's try the condition and it's pause. Okay. Yeah, okay, I see why it's not working. So basically, even though those two branches are running in parallel, all of those nodes are run only once, and this condition is also run only once. However, we would need to check this condition every frame because during the rotation, maybe the agent, like the target, might pass by. So we'll need something to make that happen. Let's see if there is something in the flow. Repeats. Repeat operation of the node. That's exactly what we need. Let's use that. All right. Let's save and try again. Oops. Small technical issue. All right. Let's see. This time it's working. Except there is an issue with the particle, I think. And looking at the graph, I can see why. It's because my onStart is repeating. So I'm just going to remove this, because what's happening is when the node starts and going alerts, it's going to place a particle and it's going to end this branch and it's going to restart just after. So yeah, we don't need the repeat here. Okay, let's skip that. But yeah, it seems like we are almost here. What are we missing now? We just need to alert align range. Yeah, well, I'm going to be honest. I'm not sure how the system is going to work. I'm not the designer in charge, so I'm just going to create a placeholder node. Let's use a wizard. Alerts nearby allies. Oh, actually, maybe the allies might be useful this time. So alerts nearby allies about target. And as you might have noticed, but because allies and targets are already part of the blackboard, the tool already completed the type for them. So there is nothing more to do for me. And I can see the preview on top here. So I'm just going to hit play. Well, sorry, create. And I'm going to save it in a for my lovely programmer. And yeah, so it's just a placeholder for him. It's going to compile, generate all the boilerplates. And here, I'm ready to start coding, except I won't because I don't really like coding. But yeah, at least we've got a placeholder node, hopefully. Let's let him finish to recompile. And as you can see, it also added it to the graph. So I can just add it here. And I'm gonna feed it with my data. Save, and yeah, here we go. Not very smart. All right, I'll stop there. So that's the end of my presentation. And as you can see, in about hopefully around 15 minutes, maybe, using a set of predefined and custom nodes, I've been able to create a simple patrol behavior and also debugging it and adding placeholder nodes. And I would say stay tuned for Unite 2024 for news about the new version of the package and hopefully getting your hands on the new upcoming demo. Thank you. And with that, I will pass over to Shani.
Hello. Don't leave yet. It's just some people are leaving. It's not the actual end of the presentation. Thank you so much, Morgan, for sharing the live demo with us. I loved how you called out certain features like the implicit casting. There are a bunch of answers, so we'll get into them soon. My screen is sharing okay? Just double checking.
Yeah, I'm
Cool.
good.
Let's talk a little bit about what's to come. Now, obviously, we can't say all that much because the legal department will hang me for material or something. But we can share a few things that we're pretty excited about and we got the okay to mention. So first of all, as I mentioned earlier, or actually as I mentioned to many of the questions in the chat, it's going to be released very soon. We are hoping to release a pre-release version either today or tomorrow. We actually took a break from coding intensively to give this webinar. And yeah, so then the full release will be next week. After that, we're going to work to bring you even more built-in nodes and conditions and give you more debugging functionalities, because we see a lot that we can do there, as well as performance metrics and other things that you'll want to see in your graph. And then a feature I'm very excited for, because I know I need it for my own game, which is utility-based decision-making, to be able to bring in more interesting decision-making for your characters, such as figuring out some fuzzy logic if you're hungry, if you're sleepy, and act accordingly. So with that, thank you so much for your time and joining us. We'll still do Q&A. I want to mention that we would love you to join us on the discussion pages with the tag behavior. If you have already been there for Muse behavior, you'll know that the team is very active there. I'm trying to answer every message and help anyone who I can and who is asking. So please join us. And with that, let's answer some more questions. If you have any more questions, please put them in the questions and answers panel. If you have put them in the chat, I will try to get to you as well. There have been a couple of questions that I've marked to answer. I did try to answer most of them in chat. Oh, take a second to breathe, Shani. Come on. All right, so we have a question from Chris. Is that allowing to pull object references from the project or the scene, not just the Blackboard? Yes, Chris, exciting new features. You're already familiar with the old package, but you can now add references directly from your project. You still can't do it directly from the scene because the graph is obviously a scriptable object and there is no way to reference the scene itself because they're two independent ones, but you can put your particle system or your sound effects directly from the scene now. Eric is asking which versions will this be available on? This will be on Unity 6 and upwards. The reason being is that we needed some serialization features to make sure everything we want to do is doable. Those who have used Muse behavior will know we tried to alleviate, to work around that by using Newtonsoft JSON, but that brought all kind of other issues and performance problems. So we decided to make the move to Unity 6. However, if you're worried about using Unity 6, you should check the Unity blog right now because there is some good news for you there as well. Another question from Matthew. Can you group nodes in a collapsible container, or is there other options for managing bigger trees? The answer is no and yes. Part one, at the moment, there are no group nodes other than, nothing collapsible. We do have that on our roadmap. We'll need to see when we can make it. But for the second part, yes, you can, because you can use subgraphs, including static subgraphs at author in time, which basically collapse everything into kind of a function method, or runtime dynamic graphs as well. Morgan, do you want to take some questions, or should I just keep babbling about?
I mean, you seems to be very comfortable doing so. I can take some.
That's all right. I'm just excited about this too. Christopher is asking, are behaviors only meant for AI? The answer is no. You'll actually see an example by Manuel when he does his Unite demo about using them beyond AI. We want to, like mentioned at the very beginning, it's not just a behavior tree now, it's a more high-level graph, and we're trying to bring you more ways to use it outside of just game AI. So yeah. What project outputs will this be compatible for? Sean, I'm not sure I understand your question. If you can please give me more context, I'll try my best to answer it. How does this differ from Playmaker? I'm not sure I can really comment about that. Is Playmaker a package on the asset store? I'm not sure. What else have we got here? Chris is asking, oh, there we go. Darren, do you want to jump on the microphone and answer Chris's question?
I can do. I actually marked it for you to answer, but I can answer anyway. That's fine.
Oh,
So yeah, but this is something that we're testing. We're always testing runtime performance with this, with as many agents as we can, and we're going to always keep improving the performance until it's a non-issue. And right now, we see no problems at the moment with it either.
So Sean, thank you for the extra context. Yes, absolutely. The goal is for it to also build for Android, iOS, VR, and all of that. Christopher, as I mentioned during the talk, unlike visual scripting, it doesn't just give you a reflection of all of the APIs and scripts at Unity. Instead, we're using high-level nodes, which you can extend and create yourselves and implement in C#. So it's going to be high performance, C# back, and you can take it how high level or low level as you want and integrate it with your own game systems and your own mono behaviors as well. I hope it answers the question. So this one is answered. No, Unity APIs, we're only trying to bring out usable nodes as opposed to just exposing everything in Unity, which is not the intention, and you can use visual scripting for it. Any plans, a future plan to make it for versions before Unity 6? Unfortunately not. We did start that way, but as I mentioned before, it meant that we had issues with serialization because there is no support for generic type serialized reference in Unity before Unity 6, which is very much needed for a lot of the things we're trying to do here. Muse behavior is not going to be supported anymore. Instead, it's gonna be just behavior. You can use the generative AI functionalities on top if you have a Muse subscription. But we want to be very clear, this is just going to be called behavior now. What you can expect, well, first of all, is the release that will be next week. Beyond that, the only things we can share is what we showed in the previous slides on what's coming. Yes, it will be free. Sorry, the question is, will it be free in the case if it's just behavior? And the answer is yes, it's going to be completely free as a package that you can download without a Muse subscription or anything. Again, we're hoping to get the pre-release version either tonight or tomorrow, and then the full release version next week. And I'll put a post in the discussion pages as soon as we've got the version out. Thank you, Danielle, for joining us. Have a great week. Awesome, Sean. Really excited. Please share what you're doing in the discussion pages. And if you need help, just message us.
Yeah, the meeting is recorded and it should be available in a few days.
About resources, there will be a sample we're working on to put on the asset store, and there will be documentation, and we're working on more resources for you.
I will add to we also will provide two simple there's already one example behavior simple that haven't changed much, but we are adding a new simple serialization, runtime serialization simple for 1.0 that should showcase how to save and load graph on agents.
Yes, Roberto, absolutely. Unity Behavior will be available to all the Unity users for free on Unity 6. And with regard to Unity 6 pricing, please check the Unity blog for the latest news on that. There's some good news. All right. Thank you all for joining us. It's been a pleasure to show our package. And hopefully we'll see you on the discussion pages. Don't forget to join us and shoot us any questions over there. Oh, Sebastian, just about the question about updating. Fortunately, no, because the entire namespace and serialization has changed. So I do recommend keeping a copy of your graph so you can move, so you can redo it. Sorry about that. I've put an explanation of it in the discussion pages. Feel free to contact me. You should be able to put both packages in the same project and then see the graphs and remake them, or just take screenshots. Thank you, Christopher, and thank you for joining us. Bye, Simon. Thank you, Sebastian. Roberto, thank you. Thank you, Eric. I'm really excited about the release myself, actually. All right, bye, everyone. The recording will be sent in a few days to the best of my understanding. We will see you soon.